Well friends, today we will do some more typical problems of electric field. These problems are very important. Each and every problem, it has appeared somewhere. So you have to be thorough with these problems. So let us go to the first problem. This problem is like this. Suppose you have two charges. Here it is Q, here it is minus 2Q. There is a distance between them. Now, you are asked to find the locus of point having zero potential. Of course, it is electric potential it is talking about. So, naturally, it is Q, and since it is minus Q, there will be somewhere, some point must be there where the electric potential will be zero. But we have to find the locus of such points. So, let us see how to solve this. Well, this is the midpoint. Well, this is D distance, and this is also D distance. It is the midpoint, and this is your x-axis, and this is your y-axis. Correct? Now, let us assume there is a point P whose coordinates are x and y. It is having a zero potential. This point is having zero potential. So suppose this is R1 and this is R2. What will be the potential due to Q? K Q upon R1 and what will be the potential due to minus 2Q? Or we can write what will be the total potential. This is KQ by R1 minus K2Q by R2, correct? Because minus sign is because of it is minus 2Q. Here we are assuming that this is 0. So naturally, your 1 by R1 must be equal to 2 by R2, or this will give you R2 is nothing but 2R1. Correct? Now what is R1? We can write it as R1 square for simplicity. This will be nothing but R1 square will be this square plus this square. Correct? So here d plus x square plus y square. What will be this distance? D plus x, because it is the xy coordinate are there. And what about R2 square? It will be, of course, d minus x square plus y square. Here we can write it as R2 square is equal to 4 R1 square. Put these values here. That means 4 d plus x square plus 4y must be equal to d minus x square plus y square. Correct? Suppose now we open up, then this will be equal to d 4d square plus 4x square plus 8 dx plus 4y square is equal to d square plus x square minus 2 dx plus y square. So now 4d square, here d square, this will become 3 d square plus here 4x square, the x square, this will become 3 x square. Then here 8 dx is there, minus 2 dx is there, so plus 10 dx, and again it will be 3 y square must be equal to 0. This can be written as d square plus x square plus 10 upon 3 dx plus y square. Correct? Or we can write it as x plus d, so x plus 5 by 3 d whole square minus 25 by 9 d square plus y square this is x square plus this 25 by 3, this is 25, this factor we are taking here, and into 2 it will give you this. So this and this we have taken care of. D square, and of course here this d square will be there, will be 0. Now this we can write it as x plus 5 by 3 d square plus y square is equal to, this will go like this, then this will be 16 by 9 d square. So this is the locus of the point having zero potential. And what is this basically? This is nothing but a equation of a circle. Correct? X square plus y square is equal to a square. So now you can see with this type of configuration, what will be the locus of the point having zero potential, and it will be a circle. So very good problem, simple mathematics, and you have to think also simply. Now we'll go to the next, one more interesting problem. Now let us see what is our second problem. Second problem is like this. You have two charges, two particles are there whose mass is m and charges on the particles are q. They are tied with a string, and at equilibrium they are making a theta angle. Naturally, it will have electric force and this is the system. This is at equilibrium, and it is making these strings are making theta angle, and this is in the air. Now suppose this system is put in a liquid. liquid whose density is rho dash and the particles, this particle's density is suppose rho. This is liquid Naturally, now it will not behave the same way as it was behaving in the air, and its equilibrium will be disturbed. But the thing is, question is, find out dielectric constant of liquid. If there is no change of angle. Now it is saying that you have to find out the dielectric constant of the liquid, provided theta does not change. Theta, whatever it was there in the air, when you dip this system in the liquid, it should remain the same. So let us see how to solve this problem. This problem has also appeared in your IIT exams. Here, what is dielectric constant? Dielectric constant is nothing but your this sigma k is nothing but your sigma r upon in the first system. Basically, what is the angle this will be nothing but theta by 2. So what will be tan theta by 2? Tan theta by 2 will be nothing but EQ upon mg in the first system, and this will be nothing but EQ m, we know rho v g, because rho is the density of the particle. In the first system. In the second system, where it is in the liquid, then what will be tan theta, because theta is not changing, nothing but EQ it will become E dash Q, electric field will change, and of course your rho Vg here basically the apparent mass will be there. Apparent mass. It is not the real mass. It will be the apparent mass in the liquid, and that will be nothing but rho Vg minus rho dash Vg. Correct? This is the apparent weight this particle will have inside the liquid. It is very simple to understand. Now, suppose if we divide these two or equate these two, then EQ upon rho Vg is nothing but E dash Q upon rho Vg minus rho dash Vg. Correct? E is nothing but, or we can write it as 1 by 4 pi epsilon 0. E will be your Q square upon, suppose this is the R distance. It is not changing because angle is not changing. So this will be R square divided by rho Vg is equal to 1 upon 4 pi epsilon 0 into K. Dielectric constant is nothing but K into epsilon 0. So this is in the liquid, electric field in the liquid. So this will become like this, and this is again same thing upon rho Vg minus rho dash V. Correct? Now most of the factors they will cut. All these things will go here. Vg will also go. Ultimately K will be nothing but 1 upon 1 minus rho dash upon density of the liquid divided by density of the particle. So this is for solving this question or any numerical problem. You need to be given only rho dash and rho. You can find out the dielectric constant. It was a very good problem, and with this, how the mass changes in the liquid, and there are so many other type of problems also can be made on this. So now we will go to the next problem. Let us see that. Now let us see our this problem. Suppose you are given a charged rod. And its length is L, and you are asked to find out what will be the electric field at point P, which is D distance away along the rod. Simply by our fundamental principle we can find out, suppose if we take this as dx, width of the rod at a distance x. Now rod is having lambda charge per unit length. So our charge will be basically dq lambda dx. This will be our charge. We already know that E is equal to kq upon r square is the electric field formula. So in this case it will become dE is k lambda dx upon x square. Correct? So E will be nothing but, you have to take the integral k and lambda, we take it outside. We can take the integral from d to d plus L. It is d because our rod is from d to L plus d. Correct? This you have to take care of. You have to be careful while taking the integral. Here it is dx upon x square, and this will be give you k lambda one upon d minus 1 upon L plus correct? We can write this thing as k lambda d L plus d or L plus d minus d, this distance is out, k lambda L upon. So this is how you can find out the along the axis electric field at any point. Now we will do one more problem like this in our next question. That is also very important. Now let us see what is this problem. In our previous problem we have taken a rod. Now let us take some other figure. This is a circular rod is there, portion of a circle. Here the charge is lambda is equal to, that is charge per unit length. suppose this arc is there, which is subtending a angle of theta 0. So we have to find out the electric field at this point. Let us solve this. Suppose this is the midpoint. From midpoint, we take a small portion, it is ds, this length is ds, and now it is subtending, suppose it is subtending a theta angle from the midpoint. So due to this charge, what will be this charge? Q, or we can write it dq lambda ds. Correct? Because charge per unit length is lambda. This will, electric field will be in this direction. It will have two components. One will be like this and other will be like this. This is also theta. This is E cos theta and this is E sin theta. But E sin theta will cancel out because when we will integrate in this portion, E sin theta will be in this direction, in this portion, E sin theta will be in this direction, and ultimately this component will cancel out. The only component which will be remaining here is E cos theta. So let us find out what is E. Here we can write it as dE for this portion. K, here K is nothing but 1 by 4 pi epsilon 0, and this is called Coulomb's constant. So dq is nothing but lambda ds, and ds is nothing but r d theta. Correct? This is your r. So what is dq here? dq upon r square. Of course, this is E cos theta, so this will be dq cos theta upon r square, and we can write this as this. dq is nothing but lambda r cos theta into d theta upon r square, or we can write it as E is nothing but k lambda upon r, and this is integral of cos theta d theta, and integral values will be from here it is plus theta by 2, it is minus theta by 2, because this is theta by 2 only. Theta 0, of course, original angle theta 0. So this will be theta by 2 minus 2 theta 0 by 2. Correct? So this will be nothing but k lambda upon r here sine theta or we can write it as k lambda by r. This will be sine theta by 2 minus this thing, so this will become 2 into sine correct. So this is how we can solve this problem. Now suppose this is semicircle, so accordingly theta 0 we can put, or at any angle we can find out what will be the electric field at the center. Or and in some problems maybe lambda is not given charge per unit, total charge is given, then you can find out lambda if total charge is q, then what will be your lambda? Will be nothing but what is this distance? This is nothing but r into theta 0. So please note that in this theta 0 should be in radians, not in degree. Otherwise you will commit mistake. So this is how these were some basic problems which have appeared in exams in JEE Advanced. So I wanted to give you some kind of exposure for this. So in my next video, I will be coming with some problems with respect to Gauss law, and that is also very important. So please, if you like this video, please do subscribe this channel. Please do like this also and forward your comments also. And on any chapter, if you want the questions, please forward the name of the chapter, or wherever you are feeling difficulty, you can send me the email, or you can send me the comments also, and I would definitely like to facilitate you. Thank you for now. Goodbye.